Welcome back. Now we'll be talking about N rate guidelines for all our crops, paying a little special attention to corn and wheat because there's a little more detail there. Now, if we look at our N rates for crops other than corn and wheat, we just have an excerpt of one of our tables from A2809, our Nutrient Application Guidelines Bulletin. You can see that for a particular crop, there's only one line. It's for all yield ranges of the crop. And where we have some differences in N recommendation, it's based on soil organic matter content. And typically, the higher organic matter content you have in the soil, the lower the N rate will be suggested. Now, for potato, there is an exception there. We do have several lines for potato because there are some differences based on yield level for potato. Now, with these guidelines here, you do still need to take forage legume credits, legume vegetable credits, green manure credits, and animal manure credits. This is just a starting place that you subtract off other credits, and we'll get into credits a little bit later. Now, if we move on to corn, okay, and specifically we're talking about grain corn or silage corn here with these N rate guidelines. Sweet corn or popcorn would be in the previous table. So our corn N rate guidelines uses the maximum return to N philosophy. So this was a philosophy that was developed in about 2004, 2005 with a number of states in the upper Midwest all agreeing to use the same philosophy to develop guidelines. We all use our own data from our own states. So our guidelines are based on numerous N response experiments conducted across Wisconsin. Some of them are small plot trials on research farms, some of them are small plots on grower fields, and there are some that are field strips in grower fields. They're all replicated and randomized. The goal of this approach is really to maximize economic return. We're not trying to maximize yield, we're trying to maximize economic return. And it's not based on yield goal or expected yield, okay? It's solely based on experimental results. When we make these suggestions for an N rate, we're assuming that minimal I have to start over.
Okay. We will start
Let me start at that slide again.
at the top of this slide.
Okay, so our corn N rate guidelines. Now, these guidelines are specifically related to corn grain and corn silage. If you're growing sweet corn or popcorn, then there's rows in the previous table that I showed. So this maximum return to N philosophy is one where we're looking to maximize our profitability. We're not necessarily looking to maximize yield. It's a philosophy that was adopted widely in 2005 across several states in the upper Midwest, where we all agreed to use the same type of philosophy to develop our N rate guidelines for corn, and we would use our own data that was collected within the state. So in Wisconsin, we have numerous sites from throughout the state. Some of the sites are small plots on research farms. Some are small plots on grower fields. Others are field strips on grower fields. They're all replicated, randomized, numerous N rates at each particular site. The goal of this MRTN philosophy is not to use expected yield or yield goal. It's really looking at these N responses. Now, when the guidelines are developed based on plots where we did a good job of managing nitrogen, okay? So we're assuming minimal losses of N. They're not plots that would have had extreme nitrogen losses because a yellow spot appears in the middle of the field because there was so much rainfall. They would not be used in the database because not all the treatments would be influenced the same. So we take care with that. And it's important that when you're using these corn N rate guidelines, that BMPs are used. You really want to manage your nitrogen the best way possible. Okay, so now we'll talk a little bit about crop response to N fertilizer, since our whole approach is based upon this. And here's an example of a site where we have nitrogen rate was applied. Here's our corn grain yield in bushels per acre. You're seeing the average yield across 4 replications, and So you can see the line going up, but here's the actual yield levels. And it's important to note we see some larger increases in yield at these lower rates, but when we get to 80 to 100 pounds, that 40-pound increment, that's not producing, it's like 14 bushel increase in yield, but we move from 120 to 160 pounds at end, and it's only 1 bushel. So not so much yield increase. So we say profitability is probably not going to happen by applying 40 pounds and only getting 1 bushel out of it. So all of our studies that we use in this MRTN approach would have graphs like this. We fit mathematical models to it, and from that we determine what the economic optimum N rate is at a particular price of nitrogen and price of corn grain. And really, just to kind of hit home here, it's the first increments of nitrogen that have the greatest efficiency and the greatest potential for economic return. And again, when you're applying N rates in excess of crop needs, so here when we're applying 160, 200 pounds of N, we're not getting any more yield compared to 120. But we put on a whole lot more nitrogen that can be lost to the environment. And that's not a good thing. It's not profitable either. This chart is showing our MRTN guidelines for corn. So we're going to walk through certain pieces of it. All the details related to this can be found in Chapter 6 of A2809. And so let's start with soil over here on the side. So that's important. When we look at our corn N rate guidelines, we break our soils. Let's start at the bottom. We have our sandy soils and loamy sands. Here we look at those particular ones, and we just break out whether they're irrigated or not. And we look at all previous crops, because the data that we have at this point, we really can't say that it makes a difference whether it's soybean or corn as the previous crop. The end response is very similar. Now if we look at what we're calling loamy soils, and in our system here in Wisconsin, loamy is a catch-all for medium and fine textured soils, meaning anything that's not sandy or loamy sand. But medium and fine textured soils is really a big phrase, and it's hard to kind of squeeze down on a lot of these little cards and tables, so we just call it loamy. So on our loamy soils, we break those into high or medium yield potential soils. And that distinction is important. We have different end responses, whether it's high or medium yield potential, but we also have to keep in mind that that distinction between yield potential is based on soil properties. So it's not something that you per se determine. It's something that we've gone through the NRCS databases, looking at the soil properties and separated them out. So the properties that we look at are water holding capacity, drainage, and depth of bedrock. So if you have shallow depth of bedrock, less than 30 inches, that's going to restrict you to a medium yield potential soil. Soils that have very low and low available water capacity will restrict you to medium yield potential. And on the drainage classes, anything that's poorly drained or very poorly drained or excessively well drained will restrict you into the medium yield potential classes. So you just need one restriction to put you into medium. In A2809, there's more description of this. There's more discussion related to temperature regimes, so that you can have a soil that has no particular restrictions with drainage, water holding capacity, or depth to bedrock. But if you're in the far northern part of the state and you're limited by growing degree days, then we'd say you really need to be using medium yield potential. So again, more details in A2809. And so we have these distinctions between yield potential, and then for either of these loamy ones, we then look at previous crop. And we can see on the top line for both of them, it's previous crops of corn, forage legumes, legume vegetables, and green manures. They're all lumped together, and on the second line, it's soybean and small grains. Now, it's important to note that there's some footnotes here, and you need to read the footnotes, okay? That's key. So on the top line, you have corn and you have these forage legumes, legume vegetables. So you do need to take your nitrogen credits for those particular legumes. Now in the second line, we have soybean and small grains grouped together. And this confuses some people because they say, hey, wait, soybean is a legume and we used to take credits for it. Well, what's going on here is we have enough data for all these experiments where corn follow corn that we can make one of those nice graphs, and then we have a bunch of data for corn following soybean where we can make another bunch of graphs. And so since we have enough data like that, what we actually do is we just make those graphs directly. So instead of saying, oh, we'll take a 40-pound soybean credit, we're actually doing a better job because we're doing experiments with corn as a previous crop versus soybean as a previous crop. Now small grains is thrown in there, and that confuses people because it's not soybean and it's not a legume. Well, when we look at our end response of corn following soy or small grains, say for example wheat, we see that the shape of the curve and the economic optimum end rate is very similar to where corn follows soybean. So what we're really looking at is a rotational kind of effect here. And so try not to overthink certain aspects of it, just follow the table. And we do have data that backs up what's going on in those tables. So the next part of using our guidelines is to move over here to the right side to look at the nitrogen to corn price ratio. And this is dollars per pound of N, not per pound of fertilizer material, dollars per pound of N, to the dollars per bushel of corn. And so if you're growing silage, you need to do a rough conversion of what your silage yield might be in a grain yield setting to get an appropriate price ratio to follow. Now, we have price ratios of 0.05. This is where we have fairly cheap nitrogen and or high-priced corn, all the way up to a price ratio of 0.2. And this is where we have expensive nitrogen and or low-priced corn. Now, for a number of years, we've been hovering in this orange with a price ratio of 0.1. So an example of this would be, say, $4 corn and 40-cent nitrogen, 40 cents per pound of N. So we'll just use this orange column with the 0.1 because that's been pretty typical for several years. It's appropriate for many growers. Now, the nice thing about this approach is that two individual growers might be at two very different price ratios. If depending on where they are in the state, price of nitrogen varies by location to some extent, when they purchase the nitrogen, how much forward contracting of their grain they've produced. So you might have somebody that is actually closer to 0.05 price ratio, and somebody that is 0.1, but maybe even might be pushing 0.15, all in the same year in the same state, because it's related to their actual business decisions that they've made on their farm. So if we just start with corn following corn, this high yield potential soil, we look at that top line, we see a number in black. Okay, that is the MRTN. That's the N rate that's maximized yield, maximized profitability at this price ratio using our database. So here it's 165 pounds per acre. Then you'll see this range in gray. Here 155 to 180 pounds of N. This is showing the range of N rates that produce profitability within $1 of the MRTN rate. So you're going to be within $1 per acre of the return you'd get if you applied at the MRTN, when you apply anywhere from 155 to 180. So what this is showing is that it's not one fixed number. You can choose price ratios that might be appropriate for your operation, but also within a range there's some flexibility to pick what might be appropriate for your situation. And we'll go into some of that a little bit later about how to pick what part of the range to be in, but it really provides growers much more flexibility to consider their operations, the experiences they've had on their operations, to choose an N rate that's acceptable to them, but is hopefully not too overly excessive with regard to over-application. So now we just want to talk a little bit more about these price ratios. And I just put this in right here so you could look at it a little bit more. So here we're looking at $3 corn to $6 corn, nitrogen 20 cents per pound of N up to 75 cents per pound of N. And I have this red box drawn here and saying, you know, if we run anywhere from 350 to 525 corn and 30 cent N to 60 cent N, this is, you know, that might be typical for 2015 coming up. And when we look at this, there's a lot of orange in here, and this means all those price ratios would go towards that 0.1 that we were just talking about. And then we moved into blue and yellow. So here again, this is showing some of the flexibility of the system. For example, if say you know the price of N when you're going to put it down, you've bought it. So there's not too much wiggle there. You kind of know what you're going to get. The price of corn is what can move around, whether you're forward contracted or not, and depending on how much you may have forward contracted. So when you're actually figuring out your N rate, what you're going to put down, let's say 35 cent N was what you were going to be paying. It's kind of cheap, but we'll just use that as an example. And let's say we were at $4.25 for a corn price that you contracted some of your corn at. So here's where you're at. So you're pushing to 0.1 price ratio. But let's say you didn't forward contract everything and the price of corn went up during the growing season. So you're able to sell corn for more. So here the 0.07 price ratio might be more appropriate. And so when you're picking within that range of N rates to choose from, that range of profitability, you can really think about where do you think the markets are moving. Do you think that corn prices might be going up in the season, and if you're kind of on that edge, maybe you want to push a little bit to a more favorable price ratio. If on the other hand you're somewhere down here where it's orange and blue and it looks like corn prices might be dropping, maybe you want to hedge and you want to move more towards that 0.1 price ratio or the lower end of a 0.1 price ratio. It just gives you flexibility to think about the operation. And here's just a graph, and this is taking some of our data, and it's from the data. So the recommendations I just showed a couple slides ago, those were for our what we'll call our 2012 update of A2009 and the 2012 database. These graphs here, I don't have updated ones for the 2012 database. This is going back to 2010. Most of the data is the same, but if you looked at actual numbers, they're going to wiggle a little bit. So I'm just warning you, if you start moving between the two slides in the video, you might see some differences, and that's what it is, and it's all good. So here we're looking at our compiled data for high yield potential soils, corn following corn. We're assuming a $4 per bushel of corn. And here we have our N rate versus our return to nitrogen. So it's our yield multiplied by $4 per bushel, subtracting off the cost of nitrogen at different price levels, okay, price ratios. So the blue, so that represents the 0.1 price ratio, so that would be 40 cent nitrogen. Green is cheaper nitrogen, orange and yellow move into more expensive N. So this is another way to look at that table where we had the MRTN rate plus the range. Here the black diamond is showing you the MRTN rate. The white diamonds are showing you that range of profitable N rates. And what's clear here is that we have overlap between profitability, there's an overlap in profitability between price ratios. So one doesn't need to necessarily lay awake all night trying to figure out which price ratio they want to be at. Just kind of be thinking about there's overlap between these ratios, so there's room to wiggle. Now, looking at the data another way, here we're looking at N rate and return to N. Again, high yield potential corn following corn. Here we've set the nitrogen to corn price ratio equal to 0.1. And now we've changed the value of corn. So we're looking at $4, $6, or $8 corn. So that means we're looking at 40 cent, 60 cent, or 80 cent N. So here the price levels are changing, and what's very clear here is the MRTN does not change because it's all still 0.1 price ratio. what you might notice here, it's a slight difference that you could see in the graph, is that that range of profitability narrows up a bit as we move to higher price levels, because it's showing that there's more risk, that there's more of a curve here. It's not so flat when we're at high price levels. Now, when we developed our tables for MRTN that we use in our guidance documents, we use a low price level. I believe we used $4 corn. So we have the wider range possible as opposed to a real narrow range. Now, we'll talk a little bit about some guidelines for using what part of the range to use. I'm not going to go into a lot of detail on these. I just want to make sure you're aware that we do have guidance, that we're not just letting you out in the woods by yourself to choose which part of the range to be in, although many folks are fine with that. Others would like some guidance. You can find more detail in A2809 Chapter 6, Nitrogen. So some of the things where we provide some guidance on where you want to be in the range, whether the low, the mid, or the high part of the range. If you have more than 50% residue cover at planting, if your previous crop is small grain, if you have 100% of your nitrogen coming from organic sources. Things like that are helpful to be looking at, maybe not just using the middle of the range. We also have some guidance on different textured soils with, say, coarse textured soils with either low organic matter or higher organic matter levels. So again, all of that is in the document. Okay, so now for wheat, we have a sort of similar process to corn for obtaining N-rate guidelines. We're using the same MRTN approach. You can see the table looks a little bit different. It's a different crop, and we looked at the data a little bit differently to see what makes sense. So again, we start with soils, and we just say, is it sandy or is it loaming? Okay, we don't break into the yield potential. We look at previous crop. That's important. Again, sandy, it's all previous crops lumped together. Now, an important difference here with wheat is that we look at the pre-plant nitrate test. Okay, we'll get into that more in a little bit, but the pre-plant nitrate test is soil samples taken down to 2 feet prior to planting to measure nitrates. And it can be used to help adjust our N rates. And we can see that for previous crops of soybean and small grain, it doesn't matter what the PPNT is. It really is if it's a previous crop of corn. And if you have a high PPNT number, we essentially have no recommendation for nitrogen for wheat. If we have say a moderate number between 51 and 100 PPNT value, we've got another set of N rates for wheat. Again, here we've got the price ratios, the nitrogen to wheat price ratio. And then where we have low PPNT values, less than 50, or perhaps you didn't take a PPNT test at all, we have another set of N rate here based on the nitrogen to wheat price ratio. So one thing that folks might notice with these guidelines compared to before we were using the MRTN approach, if we look at this 0.05 price ratio, in corn is a previous crop with no PPNT taken, our N-rate guidelines gone up a little bit, but again, we have a range of profitability from 65 to 85 pounds will produce profitability. Another important aspect where the rates have gone up a tad would be where soybean is the previous crop or small grains. We have a higher N rate. And that experience matches many of the comments I've heard from farmers and agronomists throughout the state, that when we had the old system where we had our N rate and then we subtracted that soybean credit, that the N rate just seemed too low, and if they put more on, they had a better yield. And when we look at our data and we have enough data to look at corn as a previous crop separately from soybean as a previous crop for wheat, we can see that we do have a little bit higher need where wheat follows soybean. So that's the simplicity of it. Again, there's a lot of footnotes on this table. It's important to read all of them. This too is in Chapter 6 of A2809. Now we'll move into our rotational N credits. And let's start with our forage legumes here. We have alfalfa, as previous crops where we are looking at good, fair, and poor stands. So here's the way to look at it for percent stand of alfalfa. We have red clover or bird's foot trefoil, vetch, and then we have second year credits. So we've got the first year versus second year. Now we also break this down based on soils. We're looking at medium and fine textured soils, or our loamy soils, versus our sands and loamy sands. Both of those soil groups are broken down even further to look at amount of regrowth since the last cutting. Do we have more or less than 8 inches of regrowth since the last cut, or since it's died off? So here we're looking at alfalfa as a previous crop, a good stand of alfalfa. If we had more than 8 inches of regrowth at the time it was killed, we have a credit of 190 pounds. That's a lot of nitrogen. We could move down to looking at a poor stand of alfalfa that perhaps is more typical. If you're taking the stand out, maybe you have less than 8 inches of regrowth. Oops, you're still getting a 90-pound credit. That's a substantial N credit that we need to subtract off of our N rate guidelines. And again, with sandy soils, we have lower credits than medium and fine textured soils. And with second year credit for alfalfa, well, actually for all of these crops listed here, you would use that second year credit only if you had a good or a fair stand and a flat rate of 50 pounds credit, but only on medium and fine textured soils, not on sandy soils. So it's just acknowledging that we can see 2 years out from alfalfa still some benefit as that root system, that massive alfalfa root system, is continuing to turn over and release nitrogen. Now our soybean rotation credit is 20 pounds per acre if the soybean is a previous crop. It is extremely important to remember that you do not use this with corn or wheat. Remember, we've got the MRTN tables, and previous crop of soybean is built right in. So we do not take it with corn or wheat. And the other thing, we don't use this soybean credit is on sandy soils. We've never seen a good a difference whether it's a sandy soil. So it's just a 20-pound credit. And with that, we'll take a break, and then we'll move into the next section in a moment.